you'll notice that the sample size is less than 30 and there is no known standard deviation. That makes this a t-test. So let's go ahead and pull this up in Excel to find the mean. Always need to find the mean. Just click and drag both columns. Click OK. Might as well get the standard deviation while we're here. Alright, let's get back to the problem. Okay, so the stated mean is 224. We found the sample, we found the standard error, and the sample size is 16. Let's just go through the null hypothesis testing process. First thing you do is state the null, which is just repeating what the mean is. And the alternative hypothesis is a not equal to. They don't say greater than or less than, they just say not equal to. So now let's find our t-test statistic, just like the z thing, but a little bit different. Plug in your known values. You're going to get a t-score. All right, so remember with a test statistic, they always take the absolute value of the t-score. So that equals a positive 222. Let's go ahead and look that up on our t-table. All right, what do we need to know about a t-table? Degrees of freedom, first of all, so 16 minus 1 is 15, so it's going to be somewhere on that row. And 2.22 falls between these two values right here. And so 2.22 falls between these two values, and we're dealing with a two-tailed test because it's not equal to, so therefore the t-test statistic of 2.22 generates a probability between 0.05 and 0.02. Let's double check that real quick on Excel. Okay, in Excel, pick a cell, any cell, go to the function bar, make sure you're in statistical. You're going to go down to t-dist. It's going to give us the area underneath the curve, just like the t-table. Click OK. This is important. The x in the t distribution is the test statistic, 2.22. Degrees of freedom, 16 minus 1 is 15. Tails, two tails because it's not equal to. Bam. So we got a confirmation it is between 0.05 and 0.02. So back to the problem. Okay, from the table we know it's between 0.05 and 0.02, but with the power of Excel we found out it's closer value 0.04. Let's go ahead and plug that into our final step, whether we accept or reject. And our critical value, our cutoff value, is greater than our calculated value. Therefore, we say that the data is significant at the 0.05 level, and we reject the null hypothesis. That's it. MGZ out.